Hello and welcome to the world of astronomy.
When we go deeper in electronics, we fight with two things. We deal with two things, conductors and semiconductors. Every solid conductor of electricity can be classified as either metal or semiconductor. And a semiconductor is an insulator in which at room temperature some charge carriers are mobile, and at absolute zero a pure, perfect crystal of most semiconductor would be insulator. The only difference between semiconductors and insulators at 0 Kelvin lies in the magnitude of the forbidden gap. That is the gap between the valence band and the conduction band. The forbidden gap is negatively small in semiconductors. On the other hand, metals differ from semiconductor in several respects. The most fundamental and significant difference is that metals conduct electric current by means of mobile negative charge carriers alone, whereas in semiconductors conduct electric current by means of two distinct and independent classes of mobile charge carriers. One of the two types is positively charged carriers, that is holes, and the other type carriers would be negatively charged, that is electrons. But this distinction lies at the root of the operation of all semiconductor junction devices, including diodes and transistors. Except at room temperatures, not much below their melting point, semiconductors have resistivity considerably higher than good metallic conductors, and also much less than good insulators. That is, the resistivity of semiconductors at room temperature is naturally 10 to the power minus 5 to 10 to the power 8 ohm meter. Intermediate between good conductor is 10 to the power minus 8 ohm meter, and insulator is 10 to the power 16 to 10 to the power 24 ohm meter. And the electrical resistivity of a semiconductor is usually strongly dependent on temperature, and basically semiconductors have negative temperature coefficients of resistance. Means if we increase the temperature of the semiconductors, their resistance increases.